Welcome. Here we'll take a look at a couple more examples of the chi-square test of independence. So number one, a recent debate about where in the United States skiers believe the skiing is the best prompted a survey that yielded the following results. Test to see if opinion on best ski area is dependent on the level of the skier using a 1% significance level. All right, so we've got 3 areas of skiing in the US, Tahoe, Utah, and Colorado, and 3 levels of skier. So for example, 20 beginning skiers think Tahoe is the best area for skiing. How about over here, 30 intermediate skiers think Utah is the best, etc. So we're wondering if the choice of ski area is related to their level of skiing. All right, so first step is to get this data into our calculator, into a matrix. And in this case, we have 3 rows and we have 3 columns. So the size of the matrix is called a 3 by 3. So number of rows first by number of columns second. So we'll go to our calculator and get to our matrix by doing second and then matrix. And you want to go to edit, choose your matrix A. And now I need to enter 3 and then enter, 3, enter. And then you will have your matrix available to you. So you're just going to type the values into each of those cells of the matrix. And as always, once you're done, you can use your arrow keys to fix any possible typos. And I'm just checking my data. And then we're ready to conduct our test. So the null hypothesis will be that there is no relationship between opinion on best ski area and level of the skier. So in other words, these variables are independent. And then the claim that we're testing, we're going to see if we have enough evidence to conclude there is a relationship between opinion and level of skier, so that they are variables that are dependent. All right, so we'll find our test value by running the chi-square test. So stat tests, and then instead of scrolling down, I usually scroll up. It gets me there a little faster. So chi-square test, and then our observed data we put in matrix A. You don't have to do anything with expected. The calculator will store expected values in matrix B, but we will be finding our test value here on the calculator, so we won't need to look at that matrix B, but you'll always leave that A, B. And then you can always do calculate or draw. I'm going to go with calculate. I do have the picture over here of the draw if you wanted to check that out, but let's go calculate. And there is our test value. So test statistic or test value is a chi-square value rounded to 3 places is 10.526. So there's our chi-square distribution, our skewed right distribution. Every chi-square graph is determined by its degrees of freedom, which is 4. And the p-value of the test comes out to be 0.0324, or as a percent, 3.24%. So to determine if we consider our findings statistically significant, we will compare our p-value to the significance level. So before I do that, I just wanted to label some things here now that we have the picture. So a chi-square test of independence is a right-tail test. So that shaded area is our p-value of 3.24%. And it's the area to the right of our test value or test statistic of 10.526. And we'll need to determine if that p-value is small enough to cause us to reject the null hypothesis. So we're going to use a 1% significance level. So if we're going to go with a 1%, alpha as our threshold for significance, our p-value here is not small enough. It's bigger than our alpha. So we do not reject our null hypothesis. So we don't have strong enough evidence against the null hypothesis to cause us to reject it. All right, and if we're not going to reject the null, that means that our conclusion is there is not enough evidence to support the claim of a dependent relationship between these variables. Okay, let's do one more. So tractors. So we've got Viking Equipment Inc. is a tractor manufacturer that's beginning to realize the importance of sales on its marketing of two products. So it has two main products. The Incisor is a tractor used in large agricultural settings, and the Caddy is a smaller tractor primarily used in landscape. So with the aim of maximally allocating its resources, they decide to investigate whether there is a relationship between the type of tractor that they sell and the geographic region of the sale. So in this case, our matrix is going to have 2 rows and 4 columns. So it is a matrix size 2 by 4. All right, so back to our matrices. So second matrix, come over to edit, select A, and 2, enter 4, enter to get your appropriate matrix size. And then we step through, again, each of those cells and making sure no typos. And I think I'm good. All right, and then we're ready for a hypothesis test. So null hypothesis will be that there is no relationship between the type of tractor sold and geographic region. So in other words, again, the variables are independent. And what they're wondering is whether there is a relationship. So our alternative hypothesis is there is a relationship between these variables. In other words, they are dependent. So type of tractor sold is related to the region of sale. Okay, and then we're ready for the test. So stat tests. I'm going to scroll up to my chi-square test. It's already set up, nothing we need to do there except hit calculate. All right, so now my test statistic or test value, either one, is 11.854. Degrees of freedom for this chi-square distribution is 3. And we've got a pretty darn small p-value, 0.0079. So that's not even 1%. It's even less than 1%. So very small p-value. So on my picture here, that shading there, which you can hardly see, is because the p-value area there is so small. And that test value of 11.854. All right, so we're going to compare that to our significance level alpha. So in this case, they wanted us to do 5%. Even if we had used 1%, that's still going to be a small p-value. So as always, anytime our p-value is less than or equal to our significance level, it means we have significant findings. In other words, we've got strong evidence against the null hypothesis. We are going to reject it. And therefore, there is enough evidence here to support a claim that there is a dependent relationship between type of tractor sold and the geographic region of sale. All right, and that will conclude our chi-square test of independence.